All right, welcome to Solving Problems, Part 1. And we're going to look at a finance kind of question. All right, let's read the example that I have here. It says you invest $100 each month for 12 years, getting 3.5% compounded monthly. How much do you end up with? Now, what's going on here wouldn't work with the other formula that we had. In other words, this formula here, where I have a starting quantity or a principal amount, and then I decide I'm going to grow by a certain interest rate, and then I have a number of growth periods or years. This formula here doesn't work when you do regular investments. You know, here what's happening is every month you go back to the bank and you throw in another $100. So it keeps muddying the waters. So this formula here is just not going to do it. So I have to get rid of this and use a different formula. Now, mathematicians have worked out a formula that deals with this kind of regular investment kind of problem. And I'm going to show you what that formula is, and you don't have to memorize it. Okay? So it works like this. The future value that you end up with, so future value, that's what we're looking for. It works like this. You take the regular investments that you make, which I'm going to call R, and then you multiply that by 1 plus the interest rate raised to the number of times that growth occurs, minus 1, and that's all the numerator. And then on the bottom, we have the denominator of the interest rate. Okay, so how would I set that up for this particular problem? Well, in this case, we're looking for the future value, so it's not too bad. It's just really, really messy setting everything up. So I guess the easy part of it is probably R, because that's just going to be $100, right? That's what your regular investment amount is. Then in the brackets here, we have 1 plus, because it is growing, and then our interest rate is 3.5%. But remember, it's compounded monthly. So what you got to do here is go 0.035 and divide that by 12. Okay, so that's that. And now I got to raise it to the right number of growth periods. Well, we're doing this over 12 years, and it's 12, because it's monthly, it's 12 times a year. So your exponent here should be 12 times 12 to get the correct number of growths that have occurred. And then we go minus 1 because the formula tells us to do that. And then on the bottom, remember that this is the interest rate, but it's got to be tweaked a little bit. It is 3.5%, but it's per month, right? So you have to divide it by 12. Now that's messy, but if you're careful on your calculator, you will get the right answer. My suggestion is when you put something like this through on a calculator, you know, work from the inside out. Maybe figure out this business here raised to the 144, then subtract 1 and hit return, then times it by 100 and hit return. You know, do it in stages because it's so easy to push the wrong button. All right, so you should end up with a total of $17,863.94. Okay, so that's how these kinds of finance questions work. Sometimes you have to use logarithms to solve them. In this case, I just wanted you to get to know the formula. All we had to do was put in the correct stuff in the correct spots and then use the calculator. So not a bad way of dealing with this kind of question. And as I say, this formula here would be provided. There's no way you will have to memorize a big mess like that. So that's where I'm going to stop, and we're going to come back with another finance example.